covering finding zeros of a polynomial function. And so in order to do that, we can use something called the rational zero theorem, which is a tool that can help us make our list of possible zeros, make it into a smaller list. So in order to use this, we're going to need to find the factors of the constant term and find the factors of the leading coefficient. So remember, the factors are just the numbers that we can multiply together to get that number. And so we list the factors and then we divide them to find that list of possible ones. So example 1, use the rational zero theorem to list all possible rational zeros of the function f of x equals x cubed plus 2x squared minus 5x minus 6. So here, the constant term is negative 6. Now the factors of negative 6, we can get the factors of 6. They're going to be 1, 2, 3, and 6, because 1 times 6 is 6, 2 times 3 is 6. However, we are going to include the plus or minus because we can combine these to get that negative 6. And then the leading coefficient here, remember, comes from the term with the highest degree. In this case, your leading coefficient is going to be 1. So my factors are just plus or minus 1. We write the numerator factors on the top as our numerator. So we have 1, 2, 3, and 6. And then our denominator is 1. Okay. So if we divide the numerator by the denominator, we would have 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. And 6 divided by 1 is 6. So we say that our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And so instead of an infinite number of zeros, we only have 2, 4, 6, 8 zeros to check. 8 possible zeros. Okay, so let's look at number 2. In a little bit, we'll actually find which ones are actually zeros. So right now we're just getting the possible list, and then we'll be able to find which ones are actually zeros. So the constant term here is negative 3. The factors are 1 and 3. And now my leading coefficient is a 4. And my factors here are 1, 2, and 4. So I'll write my numerator on the top, my denominator on the bottom. So I'll write the factors of the constant as our numerator and the factors of our leading coefficient as our denominator. So then we're going to divide. So I start with this one. 1 divided by 1 is 1. 3 divided by 1 is 3. 1 divided by 2 is a half. 3 divided by 2 is 3 halves. 1 divided by 4 is 1/4. And 3 divided by 4 is 3/4. So our possible zeros are plus or minus 1, plus or minus 3, plus or minus a half, plus or minus 3 halves, plus or minus 1/4, plus or minus 3/4. Okay, so now finding the zeros. So your first step here is still to go ahead and find the possible rational zeros. So the factors of my constant are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. The leading coefficient is plus or minus 1. So my possible zeros are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. So these are possible rational zeros. So your next step, so this is step 1. Step 2 is to pick a 0 and test it out using synthetic division. So I'm going to try 1, see if that works. So my coefficients for the synthetic division part, we're going to have 1, 8, 11, and negative 20. I bring down the 1. 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 9 plus 11 is 20. Times 1 is 20. So we get 0. Since we have a 0 here, then that tells us that x equals 1 is going to be a 0. Now the great thing about this is that now we can use your quotient. Remember, your quotient is the numbers that are circled here in red. Since we started with x cubed, then we're going to go with 1 less. Okay, so my quotient will be, since we started with x cubed, we'll start with x squared. So we have x squared plus a 9x plus the 20. So now we can take our quotient and actually solve for x. So you can use factoring, quadratic formula, any of the methods that you feel comfortable with, and if they work. So here I can use x plus 4 times x plus 5 equals 0. And so I set each factor equal to 0. So I get x equals negative 4 and x equals negative 5. So my zeros for this polynomial are x equals negative 4, x equals negative 5, and x equals to 1 because we saw that when we use synthetic division. Example 4, find all the zeros. So again, there's different ways you can do it. You can try to factor by grouping. That might be a possibility. I'm going to go ahead and use the possible rational zero theorem. So here I'm going to divide the constant factors. In this case, the constant is negative 2. So my factors are 1 and 2. And I'm going to divide that by the constant of my leading coefficient, my factors of my leading coefficient. So here we just get plus or minus 1, plus or minus 2. So these are possible zeros. So I'm going to use 1 and see if 1 is a 0. So 1, 1, negative 5, negative 2. Bring down the 1. 1 times 1 is 1, plus 1 is 2, times 1 is 2. Negative 3 times 1 is negative 3, negative 6. Since we get a negative 6, that means that this is not going to be a 0. So we try to the next one, negative 1. Bring down the 1. 1 times negative 1 is negative 1, plus 1 is 0. Negative 5 times 1 is 5. And this doesn't work. Okay, so we'll try the next one, 2. So we have 1, 1, negative 5, negative 2. 1 times 2 is 2. 2 times 1 is 3. 3 times 2 is 6. Plus negative 5 is 1. Times 2 is 2. So we get 0. So that makes us happy. So now my quotient comes from these 3 numbers here. Since we started with x cubed, now we're going to start with x squared. So we would get x squared plus 3x plus 1 equal to 0. Well, here I can see that this is not going to be factorable. So I'm going to go ahead and use the quadratic formula. So we get negative b, in this case is a 3. B squared is 3 squared minus 4 times a times c divided by 2 times 1. 3 squared is 9 minus 4 divided by 2. So x is negative 3 plus or minus the square root of 5 divided by 2. So I cannot simplify anymore. So my answer is that my zeros are x equals 2 right here, and x equals negative 3 plus square root of 5 divided by 2, and x equals -3 minus square root of 5 divided by 2. So this is a way to find the zeros of a polynomial.